Hello, Honors Pre-Calculus students. This is Mr. Guzzato, and today I want to talk about Descartes' rule of sign. Descartes' rule of sign tells you the possible positive and negative real zeros of a function. So here's the rule, and before the invention of the graphing calculator, this was very helpful. If you take a 400 level math class, you may also study this theory. So for f of x, the possible number of positive real zeros is the number of sign changes and I'm going to add something to that in a minute. So if we look at number 1, we want to count the number of sign changes. So the 2 is positive, so it's positive to positive to positive to positive to negative. So here's a sign change, so that's one sign change. I'll just put a little dot there. And that's negative. So there's one sign change in this function. So that tells us there's actually one positive real zero, because there is one sign change there. If we were to look at problem number 2 here, and we were to count the sign changes, so we go from positive to negative, so there's 1, and then negative to negative, and then negative to positive, so there's another sign change there. So that tells me that there are 2, and now I'm going to say or 0 positive real zeros. And my question of interest is why did I decrease by 2? If you remember, complex zeros always come in pairs. So I need to go back to this kind of definition at the top. The possible number of rational zeros is a number of sign changes, and then I'm going to kind of put in parentheses, decreased by increments of 2. Or I'll put also decreased by increments of 2. And the reason is complex zeros always come in pairs. So if suppose there were 7 sign changes, then the number of possible real zeros, positive real zeros, would be 7, 5, 3, or 1. Clearly we can't go into the negatives. If there were 8 sign changes, it would be 8, 6, 4, 2, or 0. So we can go down to 0. All right, and then the second part of Descartes' rule of sign talks about negative real zeros, possible negative real zeros. So to determine the number of possible negative real zeros, so determine the number of possible negative real zeros, you need to calculate f of negative x and look at the sign changes. So for number 1 here, f of negative x, I'm going to do this one step by step, but I know some of you can skip the steps. So it's 2 negative x to the 5th, plus 4 negative x to the 4th, plus 13 negative x cubed, plus 26 negative x squared, minus 45 negative x, minus 90. When you simplify this, you get negative 2x to the 5th. Remember, a negative to an even power is positive, so plus 4x to the 4th, minus 13x cubed, plus 26x squared, plus 45x, minus 90. So for the possible negative real zeros, you look for the sign changes. Here's 1, 2, 3, and then 4. So that means they're for negative real zeros. I'm going to erase some of this because it's in my way. So for the negative real zeros, there are 4, or 2, or 0. So in the last video, I talked about the p's over the q's. So when I was in high school, I knew that there was one positive real zero. So I would start checking the p's over the q's. Once I found the one positive real zero, I knew I found all of the positive real zeros, so I could stop. Let's just look at number 3. So for number 3, f of negative x is going to be 2x to the 6th minus 3x to the 4th minus 32x squared plus 48. So that tells me for f of x, there are 2 or 0, because if you look at the sign changes here, there's one sign change there and one sign change there. So there are 2 or 0 negative real zeros. So on this page, you can try problems 2, 4, 6, and 5, and the answers are on the second page that you can self-check.